Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we review everything you need to know for the upcoming test about parabolas. So a parabola is the graph of a quadratic equation. Their equations will either be y equals ax squared plus bx plus c, this is expanded form, or y equals this is turning point form, so called because you can easily recover the turning point. The turning point is negative hk, so the negative of this is the x coordinate, and this is the y coordinate of the turning point. Turns out every parabola does have a turning point. So if a, the number out the front here, coefficient of x squared, if it is negative, you will have a frowny face and this which is a maximum turning point. And if a is positive, then you will have a smiley face and this is a minimum turning point. Now, whether the turning point is a minimum or a maximum, the turning point always occurs at x equals minus b over 2a. So it needs to be in this form for you to use that formula. So whether you use completing the square and get the turning point from here, or you use this formula to get the turning point from there, it really doesn't matter. What really matters is that you can find the turning point, that you can find the maximum or minimum value in a parabola. So a C-level student would be able to take the equation and graph it. But if you want to be a B or an A-level student, we need to do some further work. So specifically what we're going to look at in this video is finding the equation of a parabola and also solving max or min problems. So let's get to it. So we're going to find the equation of this parabola here. Now we are given the turning point, so let's use the turning point form. The equation of this parabola can be written in the form y equals a x plus h squared plus k. So because the turning point is 4 and negative 8, it means that k will be negative 8. Now h won't be 4, it's negative 4. This number is the negative of the x value of the turning point. So what we know so far is that this parabola will have an equation of the form a x minus 4 squared minus 8. See, the thing is, however, that any number of a will still yield the same turning point. This parabola will have turning point 4, negative 8, whether a was 1, 2, negative 300. So because of that, we need to find a. How do you find a? You substitute in another point. You just pick any point whose coordinates are clear. So here we see the point 0, 0 is on the parabola. So I'm going to substitute 0, 0. That means I'm going to replace y with 0 and x with 0. I therefore have y equals a x minus 4 squared minus 8. So people sometimes get tripped up here. We've got to follow order of operations. We've got to do this first. So I'm going to leave the 0 and the a. 0 minus 4 is negative 4. Negative 4 squared is positive. I get 0 equals 16 minus 8. So I add 8 to both sides, just like a normal linear equation, and now I need to divide each side by 16. I get a is 0.5. So the required equation is y equals a x minus 4 squared minus 8. So if we were asked to give this in expanded form, all we would do is expand the brackets first. So hopefully by now you know that that's x squared minus 8x plus 16. And you just have to multiply everything by 0.5. Now 0.5 times x squared, 0.5 times negative 8x. Now 0.5 times 16 is 8. 8 minus 8 is 0. This is our answer in expanded form. All right, let's look at another example in which we're finding the equation of a parabola. So here we have the equation of a parabola. The problem is we don't have the turning point. We do, however, have the x-intercepts. So we're going to sort of reverse the null factor law. If the x-intercepts are 3 and 5, we can write the equation as a x minus 3 x minus 5. So once again, we have to have our a value here. because it wouldn't matter if a was 2, 3, minus 200. Doesn't matter what a is, this will always have intercepts at 3 and 5. Now here we know a obviously has to be negative because we have a frowny face. So how are we going to find a? We're going to substitute a point whose coordinates we know. I'm going to substitute that point, which is 0, minus 3. So to find a, I'm going to take y and replace it with negative 3. And I'm going to take x, and everywhere I see an x, I'm going to replace it with a 0. So I actually get negative 3 equals a. So negative 3 times negative 5 is 15. Now, to get a by itself, negative 3 divided by 15 is minus 0.2. So the equation here is minus 0.2. X minus 3, x minus 5. So if I wanted to write this in expanded form, I'd leave the negative 0.2. I'd expand the brackets using FOIL. I'm hoping at this stage expanding using FOIL is really quick for you. Now multiply everything in the brackets by negative 0.2. Negative 0.2x squared, negative 0.2 times negative 8, negative 0.2 times 15. This is our final answer. You started with this equation and graphed it, you would end up with that. All right, let's look at a harder example of finding the equation of a parabola. So here we're going to find the equation of the parabola that goes through these points. Now this is harder because we have neither the x-intercepts nor the turning point, so we can't use one of the tricks in the previous examples. So we do know that y equals ax squared plus bx plus c. That is the general form of the equation of any parabola. Any parabola has an equation that looks like this. Now c is always the y-intercept, so here the y-intercept's 5, so I can just replace c with 5. So now I just have to find a and b, and hopefully you're thinking if you have to find two things at the same time, simultaneously, we use simultaneous equations. We're going to get one equation from this point, one from this point. So I'm going to substitute 1, 8 into this equation. That means I'm going to replace y with 8, and I'm going to replace x with 1. So a times 1 squared is just a, b times 1 is just b, and then I have my plus 5. Subtracting 5 from both sides yields 3 equals a plus b. Now I'm going to substitute this point into the equation. So I obtain y equals a times x squared. So a times 2 squared is 4a. Then I'm going to substitute x for 2. So I get 2b plus c, which is 5. So that means 8 equals 4a plus 2b. So we solve these two simultaneous equations by elimination. So because neither the a nor the b in these equations has the same coefficient, we need to multiply one or both. I'm going to multiply this equation by 2. So this equation becomes 2a plus 2b equals 6. I multiplied everything in this equation by 2. So I'm just going to write this equation down here. So it is 4a plus 2b equals 8. So I want to eliminate the b's because that's the one with the same coefficient. So I subtract. So I'm going to go 4a minus 2a is 2a. 2b minus 2b is 0. That's why we did it, to eliminate the b's. And 8 minus 6 equals 2. I get 2a equals 2, and so a equals 1. So what does that mean b is? Well, you can just substitute that into any equation. I'll substitute it here. If a plus b equals 3 and a equals 1, then clearly b equals 2. The equation is therefore y equals ax squared, a being 1, plus bx plus c, and we're done. All right, let's now look at some max-min problems. So a C-level student knows that the minimum or maximum value of a quadratic function occurs at x equals minus b over 2a. On the other hand, a B-level student will be able to solve a question like this, where we're going to have to come up with the quadratic function ourselves and then find its minimum or maximum value. So here we're told price of a hotel room is given by P equals 400 minus 5x. Price equals 400 minus 5 times the number of customers. So basically what this means is if the hotel room was $400, they'd have no customers. If it was $395, they'd get one customer. If it was $390, they'd get two customers, and so on. Basically, you start at $400, and for every $5 price decrease, they would get one extra customer. Okay, we're going to calculate the maximum possible revenue. Well, we can't do that unless we have a function that represents the revenue. So revenue is quantity sold times price. So price is 400 minus 5x. The quantity sold, the number of rooms sold, is x. So I want to basically find the maximum value this function here can take. So to do that, I'm going to need to expand. So I get 400x minus 5x squared. Okay, if you were to graph y equals 400x minus 5x squared, it would be a frowny-faced parabola. We're looking for this value, this maximum value that it can take. So there are two ways you can do this. You can either use completing the square or x equals minus b over 2a. I think that way is easier, so I'll show you that way here. So x equals minus b over 2 times a. So if you need your calculator, no worries, you should get x equals 40. So that's not the answer. It's saying the maximum revenue occurs when there are 40 customers, and so if I want to have 40 customers, the price needs to be 40 minus 5 times x, which is 40, which is 200. The maximum revenue is 40 customers paying 200 each. 40 times 200 is 8,000. That is the maximum revenue. We came up with the function ourselves. It was a little tougher. That's why it's a B-level question. Let's now look at an A-level question. So in the previous example, we were sort of half given the function for which we need to find the maximum or minimum value. Here we're not given anything at all. This is just a harder question, which is why I would consider it an A-level question. So 3 sides of a paddock, a fence using 160 meters of fencing, calculate the maximum possible area. So let's draw a diagram. We have 3 sides of a rectangle fenced. We want to know the maximum possible area this could be if it is 160 meters all the way around. So let's start by letting x be the width. We really need to find the width and the length here. So I'm going to let for now the length be y. So the area of this is clearly x times y. The problem is we don't really know how to solve equations or find maximum or minimum when there are 2 different variables. We need to write y in terms of x. So if it's 160 all the way around, this length is 160 minus x minus x. This is 160 meters minus 2x. So I'm going to replace y in my area here with 160 minus 2x. So here is a function for the area. In order to find its max or min value, we have to expand it. So it was a bit of hard work and required a bit of ingenuity to come up with this function. But now that we have the function, finding its max or min value is exactly the same. The max or min value occurs when x equals minus b over 2a. That is when x equals minus b over 2 times a equals 40. The maximum area occurs when x equals 40, so that means that this side here will be 160 minus 40, which is 80. The maximum possible area, I'll just call that max A, is 40 times 80, 3,200 meters squared. We know it's going to be a maximum because this function here would be a parabola that's a frowny face, so it would have a maximum rather than minimum turning point. All right, thank you so much for tuning into this video. Best of luck studying, but you will ace the test. You're a superstar. This has been the luckiest maths teacher in the world. Have a great day.